All right, today we're going to solve power equations. Uh, these are numbers with exponents set equal to other numbers and exponents. So for now, we call them power equations. Now, in order to solve such equations, two things we have to remember when you have a power, you have a base number and you also have an exponent. Now, the first thing to notice about our equation here of 2 to the x plus 3 equal to 2 to the 2x power is that number one, we need to solve for the variable x. And also, you notice that on both sides, our powers have the same base number. So since the base number is the same, then we can just concentrate on just the exponents. So if our expressions are the same, that would mean that our exponents will also be equal. So we can rewrite our equation as x plus 3 equal to 2x. And now we can solve our equation. I'm going to begin by subtracting x on both sides. And so this will give me 3 equal to 2x minus x is just x. Therefore, x is equal to 3. All right? And we can also check this. If we substitute 3 in for x on either side, we get 3 plus 3 will give me 2 to the 6. And then substitute 3 here, that'd be 2 times 3, which is also 6. So that'd be 2 to the 6 equal to 2 to the 6. Since both sides are equal, then our solution, x equals 3, checks out. All right, let's try another equation. Here, we have 3 to the 2x plus 1 equal to 3 to the third power. Again, we see that both of our bases are exactly the same, so we can concentrate on our exponents since they are drastically different. So we can rewrite our equation by writing 2x plus 1 equal to 3. Make my plus sign more clearer. 2x plus 1 equals 3. Again, solve our equation, subtracting 1 on both sides here. So it gives me 2x. 1's cancel. 3 minus 1 is 2. Divide 2 on both sides. X is equal to 1. All right. Again, we can check our solution here. You have 3 to the 2x plus 1 equal to 3 to the third power. So we're saying x is 1. Substitute 1 in for x. We get 2 times 1 plus 1, which gives me 3 to the third power. And that is also equal to 3 to the third power on the other side. Since both sides are equal, that means our solution here for x equals 1 checks out. All right. Now, take a look at this. We have 9 to the x power equal to 3 to the 40th power. Okay. Slight problem here. Our bases are not the same. And we see clearly our exponents are not the same. So I can't go setting my exponent equal like I did the last one because there's a problem with our bases. And let's see if that's making a connection between our bases 9 and 3. Well, one thing you may know, if we're talking about powers, that 9 is equal to 3 times 3. And 3 times 3, written with an exponent, will be 3 to the second power. And so I can substitute 3 to the second power for 9, 3 to the second power, raised to the x power, equal to 3 to the 40th power. All right, now let me finish simplifying this using my rules of exponents. Using the power rule here, that means I will multiply 2 times x, which gives me 2x. So it gives me 3 to the 2x power equal 3 to the 40th power. Now I'm back to my bases being the same, and now I can set my exponents equal. So that'd be 2x equal to 40, and 2 times 20 will be equal to 40, therefore x is equal to 20. All right, now, again, going back and checking our answer here, if we go (9 to the 20th power equal to 3 to the 40th power), and then again, substitute 3 to the second power for 9, that'd be 3 to the second power raised to the 20th power equal 3 to the 40th power. And again, applying the power rule, I'll multiply the exponent 2 times the exponent 20, which gives me an exponent of 40, and it is equal to 3 to the 40 power. So my left and right side are equal, which means x is 20. All right, let's look at our next equation here. Next power equation. Here we have 1/3 raised to the 2x plus 1 is equal to 3 to the 5th power. Now again, we notice we have a problem. 1/3 and 3 are not the same. But no fear, let's see if we can determine a connection between 1/3 and 3 using exponents. Taking 1/3 here, if I can rewrite 1/3 using an exponent, I could do 1/3 to the first power, but that doesn't quite give me the same base. If I apply the rules of negative exponents, that means if I take 3 and put it into the numerator, basically taking the reciprocal of my fraction here, that would give me 3 to the negative 1 power. So that would give me the same base here. So if I apply this here, so I can replace 3 to the negative 1 with, replace 1/3 with 3 to the negative 1 power. So I got 3 to the negative 1 to the 2x plus 1 equal 3 to the 5th power. All right, let's simplify this left side here. Using the power rule again, that'd be negative 1 times the sum of 2x and 1. That would mean this would be 3 to the negative 2x minus 1 power equal 3 to the 5th power. Now that I have my bases the same, I can rewrite my equation as negative 2x minus 1 equals 5. And now solve my equation. again by adding 1 on both sides here. Give me negative 2x. Zeros cancel here, be equal to 6. Then divide negative 2 on both sides. And this will give me x equal to negative 3. All right. Now, I'll leave that for you to go back and check. Now look at our next equation. 8 to the 70th power equals 2x. Now, again, our bases are not the same, but what connection can we make between 2 and 8 in the realm of powers? Well, here with 2, I can't get it up to 8 because all I have is just to the x power, which is unknown. But here with 8 can be rewritten as 2 times 2 times 2, which is also 2 to the third power. So I can replace 8 with 2 to the third power. So 8 being replaced with 2 to the third power, still raised to the 70th power, is equal to the x power. Now, again, applying the power rule, the power of 3 times the power of 70, that'll give me 2 to the 210 power equals 2 to the x power. And now, my bases are the same. I can rewrite my equation using only the exponents. That'll be 210 equals x. It looks like I already have my solution here. So x is equal to 210. So, in short, to solve power expressions, you begin by making sure your bases are the same. And if your bases are the same, then you rewrite your equation using the expressions for your exponents to solve for x. And remember to go back and check both sides, determine if they're equal. And if both sides are equal, then you know you have solved it correctly.